Howdy, partners. Okay, so another example that we have to calculate the centroid of areas by integrals. Same procedure again. First thing that we have to do is knowing our equations. Of course, let's start with x, and x bar is going to be the integral of y dA divided by, x dA divided by the integral of dA. So our objective first is finding that dA, and if I'm measuring x in this way, it's pretty obvious that the dA is going to be this. And not only is obvious that it's that, but it's feasible. I mean, you can change the height with no problems, and that height is going to be defined by any point in this line and any point in this line, which would be this y minus 0, because in this line this is y equals 0. So my integral of the differential of area, or my differential of area, is going to be this, which is y minus x plus 1 times this, which is dx. There you go. Now if I have to find the area first, then I have to do the integration of that. The integration of x squared minus x plus 1 dx. And remember, this is going from 0 to 2, because that's the same way that we are running our differential of area to form our chart, our area. So from 0 to 2. And then we do this integral, that's it. So this is x to the third divided by 3 minus x squared divided by 2 plus x from 0 to 2. And the integral of my differential of area, which is my area, is going to be 2.6 periodic and units squared, whatever the units in this problem were. Remember, this point is 2 here. Now, if I want to calculate the top part, the integral of x dA, well, then I do the integral of x dA is going to be the integral of x multiplied by my dA, which is x squared minus x plus 1 dx. And once again, from 0 to 2. Then we solve for this, and this is going to be the integral from 0 to 2 of x to the third minus x squared plus x dx. And when we solve this, this is going to be x to the fourth divided by 4 minus x to the third divided by 3 plus x squared divided by 2 between 0 and 2, which gives us a value of 3.3 periodic. At the end, and this should be cubic units, and at the end we have to apply this. X bar is going to be equal to the integral of x dA divided to my integral of dA, and this is 3.3 periodic divided by 2.6, which is also periodic, and my x bar is equal to 1.25 units. There you go, straightforward, this part. Now, when we look for the other situation, let's try to work it out in the other way that I tell you to work, if it's possible, which is measuring in this direction a value. So let's say that I want to measure, now in this way, and I want to measure y, and then my differential of area is going to be this one. That's not possible. Look, this part, I'm integrating it, and it doesn't exist in that curve. So this is an indication that using this procedure for this part is not going to work. So I have to use the same differential of area that I used before. Just remember that the center of that differential of area is going to be exactly the center of that line. This is the wiggle y, or the y wiggle bar. In this equation for y bar is the integral of this y dA divided by the integral of dA. This is my equation. this is the y that I have to use if I keep the same differential of area. Now, what is this wiggly y? Half of this. I know that the total of this is this height, so this wiggly y is going to be x squared minus x plus 1 divided by 2, because that's the distance to the centroid of that shape. And then I can use the same one. I have this. I'm just going to solve for this part. So the integral of y dA is going to be the integral of this x squared minus x plus 1 divided by 2 times this, and this is this part here, which is also x squared minus x plus 1 dx. From the same limits, because once again I'm using the same differential of area, meaning I'm running my shape in this direction. So it will be from 0 to 2. And then I solve for this. When I solve for this is going to be 1/2. I'm just taking this outside of the integral from 0 to 2. This times this, this times this, this times this. So this is going to be x to the 4th minus 2x to the 3rd plus 3x squared minus 2x plus 1 dx. And when you solve this is going to be 1/2 of x to the 5th divided by 5 minus 2x to the 4th divided by 4 plus 3x to the 3rd divided by 3 minus 2x squared divided by 2 plus x, evaluated between 0 and 2, which gives us a value of 2.2. And my y bar then is going to be the integral of y dA divided by the integral of dA, which is no other thing than 2.2, the value that I just got now, divided by the previous value of area that I had before, 2.6 periodic, and that gives us a value of 0.825. You see, in this case, finding if we do it in the other way, it would be extremely difficult to do, but doing it and using the same differential of area is a lot easier. So once again, it's up to you. You have to figure it out which one works the best for you and in which occasion works the best for you. Hope you enjoy the video, and keep watching and learning, and try not only to watch but try to solve the problems. As I always say, go solve the problems by yourself. Stop the video, copy the problem, solve the problem, and then if you get stuck somewhere, watch the video. And even if you don't, because maybe I'm using a different procedure that will add up something to your knowledge, I don't know, hopefully. See you next time. Have a good day.